Hey guys, today we're going to be looking at determining whether a set of ordered pairs is a function or non-function. We're also going to be looking at using the vertical line test to determine if a graph is a function or not a function and whether it's linear or non-linear. And we'll also be looking at the mapping diagrams using the ordered pairs, a set of ordered pairs, and determining whether it is a function or non-function using those ordered pairs. So let's just kind of just a brief recap what we talked about the other day in class. We're looking at a set of ordered pairs. So if I have the set of ordered pairs, let's say 3, 5, 2, 6, negative 4, 3. Just a real short, quick, easy set of ordered pairs. But if I'm looking here, remember what we're looking for. Remember, a set of ordered pairs is any x and y variable that I can use to plot a point on the coordinate plane. Well, if I'm looking here, remember we said the first line, the first number in each one is the domain, the x values, or all of the domain, or all of the x values in this set of ordered pairs. Well, in this case, all of the domains, or all of the x values, are these three numbers that I have circled. Well, remember, we want to try to put them in order from least to greatest. So if I'm doing these, my domain for this set of ordered pairs would be negative 4, 2, and 3. Okay, so remember, domain are all of the x values. Well, range will be all of my y values in this set of ordered pairs. So here it will be my range would be the ones I have underlined. And we'll try to put those in order from least to greatest would be 3, 5, and 6. Okay, so this is my domain, this is my range. Now, remember we talked about trying to determine if this is a function. Really all I'm concerned with is I'm determining, do I have an x value that repeats? Well, in this case I don't, because I have a 3, I have a 2, and a negative 4 circled. None of those values repeat, so this one would be a function. Okay, let's look at one more just to kind of make sure we got a handle on this. Okay, so if I do something like negative 2, 6, 5, 4, negative 2, 8. Well, here we do our domain. Again, are all of my x values. And then the range are all of my y values. Okay, so the domain here, I'm going to circle the first letter, the first number, excuse me. Well, in this case, I have three numbers circled, but if you'll look here and here, these two numbers are the same, so I'm only going to write that domain one time. We don't write repeating numbers, because when I write it, it takes care of both of them. And then the range of the domain will be 5. Well, the range, I have three different numbers, so I will put them in order: 4, 6, and 8. Well, if I look, I have three ordered pairs. Well, I only have two numbers in the domain. That lets me know that something is repeating. Well, in this case, the negative 2 repeats, so this one would be a non-function. And remember, when we do this, when we tell someone it's a non-function, we want to tell them why, because the 2 in the domain repeats. I'm sorry, the negative 2 in the domain is repeating. Okay? So that lets me know now that this is a non-function. Let's look at one more, and we'll move on. 6, negative 3, 5, negative 3, and 2, negative 3. Well, domain again is the first number in each one. So if I look, I have a 6, I have a 5, and I have a 2. So in order, least to greatest, 2, 5, and a 6. The range will be all of the y values. Well, here, if you look, they are all the same, negative 3. So I'm going to write that number one time. Well, even though I have three numbers on the road at once, all I'm really concerned when I'm determining a function is I'm looking at these three numbers. Well, they're all three different numbers. None of the x values repeat, so this one will be a function because none of the elements in the domain are repeating. Okay? All right, let's look at what we would do with a graph. Okay? So we're doing our graph. So we're going to use, remember we talked about using the vertical line test. And all that vertical line test tells me is I'm going to look, and I'm going to look across here. I'm going to drag a vertical line, and I want to drag it across to make sure that it doesn't touch this blue line in more than one place. If it does, it would fail the vertical line test and would make it not a function. So if it fails the vertical line test, it's not a function. If it passes the vertical line test, it's a function. Well, let's go ahead and do what we did in class. First off, we know that this set of ordered pairs that form this line is a relation. And we look, my line is straight, so it's going to be linear. Now let's determine if this is a function or not. Well, we're going to take our straight line. Remember, I use my line on the edge of this paper. And as I go across, as I drag across, I'm using the edge of this black line, this black paper. And all I'm doing is watching right here. I'm watching this blue line. I want to see if it touches the blue line in more than one place. Well, as I'm moving along, here it's only touching one place, which is right here. As I move along, if I stop, it's only touching right here. So as I keep going, I notice that it's only touching in one place at any given time. Whenever I stop it, there it is. Doesn't matter where I stop it, it's only going to touch in one place. Okay, so this one would pass the vertical line test, so that means this graph is a function. Okay, so that's all we're doing, is just determining, does it touch in more than one place. Alright, let's go to the next one. Here's one that's got a little curve in this one. So right now, before we do anything, let's go ahead and write relation. And since it does have this curve, remember we're going to say this one is non-linear, which is because it's not a straight line. Now let's determine if it will pass the vertical line test. Okay, here's my line. Remember, we're dragging across. And all I'm doing is looking for this blue line. I want to see if the black on my line touches the blue at more than one place. Well, as I'm easing across, I'm not seeing it touching yet. All I'm seeing is it touching one place as it goes across. Here's the curve. And as it turns up, still only one place. It's just touching right here. So as I go across, that one also is a function. Okay? So it's just determining what is it doing. Is it touching in more than one place or is it not? Let's look at one. Let's look at one more. All right. So here we know it's a relation. Look at my line. Is it straight or is it curved? This one is straight, so it is linear. Now let's determine if it's a function. We're going to drag across, and again, I'm doing the same thing. All I'm doing is looking for this blue line into my black on my paper. If it touches, just keep dragging to see if it touches in more than one place. Once you see it touching more than one place, you can stop because it's not a function. And as I keep going, and I'm seeing it not touching but in one place at a time. So we have another function. Alright, let's try one more so you see what I'm looking at here. Okay, let's try one more. Alright, now look at this one. This line is going up and down. This is a vertical line. So right now we know it's a relation. We know it is linear because it is a straight line. Now let's see if this one will pass the vertical line test. So we're going to keep dragging until we get over here. And as I keep dragging, what I'm looking for my line. And there's my line. Well, if I look, my black line is touching this at every point on the line. It's touching right here. It's touching everywhere, all the way down. It's just at every point, it's touching the line. So once you see it touching more than once, this becomes a non-function. Now, let's talk a little second about why it is a non-function. Well, let me erase this. Okay, what you're looking here is if I was to plot those points that I just erased. If I was to say, let's just pick a few points instead of all of them. Let's just pick this point here. Let's pick point here, and this point here. Well, if I was to plot this point, if I was to write the coordinates for this point, I would go over 1, 2, 3, 4, 5, up 5, 6, 7, 8. So the coordinate for that one would be 5, 8. This coordinate would be 5, 3. This coordinate would be 5, 0. This coordinate would be 5, negative 5. And I think that's all. Well, as you can see, remember what makes a function not a function is if the x value repeats. Well, in this case, all of my x values are 5. So that makes it not a function. So we can see it visually, and we can also see it with a set of ordered pairs. But remember, all vertical lines are also not a function. Let's try one of these. All right, now we have a parabola. We have a curved line. So what we say here is this is a relation. It is non-linear because it's not a straight line. And let's see if it passes the vertical line test. Well, as I pull across, I start seeing my line. Well, here it's only touching at one place. As I keep going, I'm watching it. I don't see it. I don't see any more spots that it's touching other than this one spot at the same time. And it should start swinging back up right here. And as we go, it only touched at one place at any time. So this one is a function. Now, just to give you a couple of examples, if I look, let's just pick a couple points. If I pick this point, if I pick this point, maybe this point, and this point. Well, if I start plotting those points, this point would be negative 5, 6, 7, 8. So this is negative 7, 8. This is negative 5, 3. This is 0, negative 2, 5, 2, and then 7, 7. Well, as you can see, all of my x values are different. That's what keeps this one to be a function. All right, let's go to the next one. Let's see what we got. All right, let's try this one. All right, so if I look at this one, it's a relation. It's not a straight line, so it's a non-linear relation. Now let's see if it is a function or not a function. Well, if I start dragging my line again my paper, remember we call it a vertical line test, but we said use a piece of paper. And right here, automatically, when I see right here, all I need to see is one place that it touches twice. And I don't have to go any further. This is not a function. Okay? Not a function. So this is a relation, nonlinear, non-function graph. Okay? That means here, whatever this value of x would be, what would be 1, 2, 3, 4. Let's just say 4.5. So it would be negative 4.5, probably negative 0.5. And then this one would be negative 4.5, probably what, 2.5. But as you can see, my x values are the same. That's why it failed the vertical line tests. Okay? Alright, let's look at a mapping diagram. And we talked about these mapping diagrams in class today, and we looked at the point to where what we're doing is we're trying to draw and match up the ordered pairs in the ovals below. So remember, we're going to kind of go back to what we did first. Here's my domain and here's my range. So let's find the domain first. Here are my domains. Remember, we'll put them in order, least to greatest. So negative 5 is the smallest, and then negative 2, and then 0, and then 5. Okay? You don't have to put them in order as far as once you do them in the domain, range, and the oval, but I like to get them out of the way and put them in order. So we have 4, 5, 7, and 8. So if we start writing these, negative 5, negative 2, 0, 5, all I did was take these numbers, bring them down here. Then the range is 4, 5, 7, and 8. Well, all right, let's do our map. And all we're doing, we're mapping. I'm going to look at this set of ordered pairs. I'm going to draw a line from the input to the output. Okay? So the input, when I have 5, the output is 8. When my input is negative 2, my output is 4. So I'm going to draw a line from negative 2 to 4. Well, this input of 0 gives me an output of 5. And this input of negative 5 gives me an output of 7. All right? So before we do this, let's kind of talk about this. Is or are these ordered pairs a function? Negative 5, negative 2, 0, 5 is a function because none of the x values repeat. Okay? So let's remember, if we talk about if all I give you is this, so let's take the revealer and let's do this. If I don't give you any of that, and all I do is I give you the ovals with the domain and range inside, we're looking here. These numbers, none of them repeat, but remember what we're looking for is the number of lines. You can only have one element in the domain paired with one element in the range, which means you can only have one line coming off of an element in the domain. Well, the -5 only has one line. The -2 only has one line. The 0 only one line, and the 5 only has one line. So if it was a function here, it's going to be a function here. Okay? Just pairing them up and matching them. Okay, let's try the next one. -4, -4. So here my domain is -4. I don't need to write it but one time, because once I write it, it takes care of all of them. Well, my range, there's a -4 in the range. Remember, these two are not the same. One is domain, one is range. So -4, 2, 6, and 9. So if I was to write my domain, there's -4, and my range, -4, 2, 6, and 9. Well, let's match them up. This -4 goes to a 2. This -4 goes to 6. -4 goes to, that didn't quite go to 9. Let's fix it. -4 goes to the 9, and -4 goes to -4. Well, up here, we said up here, this is a non-function because the 4 is repeating, correct? The -4. Well, let's look down here. Well, if I look in here, I only see one number, but I see 1, 2, 3, 4 lines coming off of this number. That lets me know that this domain is paired up with 4 values in the range. So we can't have that. So we can only have one value in the range paired up with the one in the domain. So here I have 1, 2, 3, 4 again. So this is a non-function. Okay? So again, all we're doing is looking. This tells me that the 4, because the -4 is repeating. Okay? Let's try the next one. The domain here, if we put them in order, I think I already put them in order. -15, -12, -5, -1. Well, my range, they're all the same number. Okay, so let's feel this is an easy one. We'll just put the 52 right here, and then we'll start writing our domains. -15, -12, -5, -1. Well, the -15 is paired with 52. -12 is paired with 52. -5 is paired with 52. And -1 is paired with 52. Well, this is a function here because none of my domains repeat. So it should stay a function here. And let's see. Well, all of these numbers are pointing to 52. But if you'll look, each number only has one line coming off of it. Each element in the domain only has one line going to the range. So it's only mapped over to one number. So this is also going to be a function. Alright? Alright, let's try one more thing. There's one more. Oh, that's all. Okay, so remember, all we're looking here is all we're doing to determine if it's a function, just count the lines. Okay? Alright, here's a quick trivia, not a trivia, but let's see what you can do. If I give you these ordered pairs, 3, 6, 2, 4, 9, 8. Okay? What I want to know first off, is this a function? Well, let's look. 3, 6, leave 3, 2, and 9. So this is a function. Let me write that a little bit better. This is a function because no element in the domain is repeating. Okay? No element in the domain is repeating. Remember, we said element is nothing but a number. No element in the domain repeats. Alright, now let's make a mapping diagram. That's part 1. Part 2, quick mapping diagram. Doesn't take very long to do this one. So 2, 3, and 9 is my domains. Let me fix this one. This is a little small. And then we have in the range 4, 4, 6, and 8. Well, if we match them up, remember 3 is matched up to 6, 2 is matched up to 4, and 9 is matched up to 8. And normally they don't always go across like that, but that's what it works out to be. All right, now let me ask you this question. And I want you to kind of pause the video after I ask the question and see if you can come up with the answer. Is there another ordered pair that you can give me that would make this function or this relation that we determined was a function? Is there an ordered pair that you can give me that would make this function stay a function? Okay, I want you to stop the video just for a couple minutes and I want you to think about it, and then I want you to write down your answer and let's see what we got. Okay, did you do it? Good. So let's talk about this. So what I want to do is any ordered pair. What I'm looking for is I want to write any ordered pair I can come up with to make this stay a function. Well, all I'm concerned with are these three numbers right here. 3, 2, and 9. So any ordered pair you give me, any ordered pair, as long as you do not use 3, 2, or 9 as the x value or as the domain, any one of those three, anything other than those three numbers would give me another number that makes this stay a function. So I could use something like 100. I can even use the 6. Doesn't matter as long as it's not one of these three numbers. 212, -8,000, and 1/2. Doesn't matter as long as I don't use those three. Okay. All right. Let's try one part. Part 4. I want you to stop the video after I ask you this. Can you give me an ordered pair, any ordered pair you can think of, that would make this function a non-function? Okay, so stop the video and I want you to think about it just a minute and then see if you can come up with an answer. Okay, all right, what'd you come up with? Well, if I'm looking, again, all I want to do is I want to make sure that I don't use these three. Okay, that I do not use these three. So what I'm looking for is any ordered pair that this time includes the number 3, 2, and 9. So this one does not use 3, 2, or 9. And I need any ordered pair here that does use 3, 2, or 9. So something can be like 3, 100, 2, 50, 9, 1/2. It doesn't matter. Anything where you make that domain repeat. Okay? Any ordered pair, whatever you come up with, as long as it's one of those three, makes this a non-function. Okay? Let me write that a little bit better, sorry. Okay? A non-function. Okay? So kind of think about that. We're going to be doing a few more of these. It's kind of like to prepare you for the test. So kind of look at those and we'll talk more about it tomorrow. Okay? Have a great evening.